Now we are going to study about the kernel. The kernel is the most important part of the operating system. It is the core component that manages all the system resources and acts as a bridge between hardware and software. Whenever any application wants to perform operations like reading a file, writing the data to disk, using the CPU, accessing the memory, it cannot directly interact with the hardware. Instead, the application sends a request to the kernel. The kernel then communicates with the hardware and performs the requested operation. As it is a core operating system, it manages hardware resources and system operations as well. Because the kernel manages critical resources, it must operate with high security and reliability. The kernel always remains loaded in memory while the computer is running. This ensures that it can immediately respond to the system request. The kernel also provides system call which allow applications to safely access hardware resources. Without the kernel, the operating system cannot function. Now let us understand that what are the kernel responsibilities, as because without kernel the operating system cannot perform its function. The kernel responsibilities include process scheduling, memory allocation, device control, file management. The kernel performs several important tasks that keep the computer system function properly. One of the main responsibilities of the kernel is process management. The kernel creates and manages the processes. It decides whether which process gets the CPU time and for how long. This process is known as CPU scheduling. Another important responsibility is memory management. The kernel management the kernel manages the system's RAM and ensures that each process receives enough memory to execute. It also ensures that the process do not interface with each other's memory. The kernel also performs device management. Hardware devices such as printers, keyboards, and disks require special programs that are called device drives. The kernel uses these drives to communicate with the hardware devices. Another responsibility of kernel include file system management. The kernel organizes files on storage device and manages file access, storage and retrieval. The kernel also ensures system security and protection by controlling access to the system resources. Now moving that how many types of kernels are there? Basically, there are three types of kernel, namely monolithic kernel, microkernel, hybrid kernel. The first type is monolithic kernel. In this type, all operating system services run inside the kernel space. This include device drives, file systems, and memory management. The second type is microkernel. The microkernel architecture is the only and the most essential service remain inside the kernel. Other services run outside the kernel in user space. This is designed to improve stability in the system because in external services because like external services may not crash with the entire system. The third type is hybrid kernel. Hybrid kernel combine features of both monolithic and microkernels. They keep performance critical and the components inside the kernel while moving other components outside. And the example of this hybrid kernel include Windows NT, Mac OS. Now, understanding these types of kernels will help us to see how each operating system balances its performance, security, and reliability. Now, moving forward with the monolithic kernel, a monolithic kernel is a kernel designed where all operating system services run inside the kernel space. This means that the kernel contains process management, memory management, file systems, device drives, and networking. Because everything runs in the same memory space, the communication between these services is very fast, as it also have direct interaction with the hardware. This improves system performance. However, the major disadvantage that is the kernel becomes very large and complex. And if one part of the kernel fails, it may affect the entire operating system. Therefore, monolithic kernels provide high performance but low fault tolerance. The ability to handle fault is low. Now let's see what are the services that a monolithic kernel provides. A monolithic kernel provides following services, namely process management, memory management, file system, and device drives. The monolithic kernel provides several services that manage system operations. The first service is process management, which controls the execution of the program. The second service is memory management, which handles allocation and deallocation of the memory. The third service is file system management, which manages file stored on the disk. Another service is device drives, which allows the operating system to communicate with the hardware devices. All these services run within the kernel space and interact directly with each other. Because they share the same memory space, communication is very efficient. Now, what could be the benefits of monolithic kernel? Let's see. Its benefits include fast service communication, high efficiency, better performance. Monolithic kernel provides several benefits. One of the major advantage is high performance. Since all the services operate in the same memory space, communication between the components is extremely fast. Another benefit is efficient resource utilization. The kernel can directly manage hardware resources without needing additional layers. Monolithic kernels are also relatively simple to design initially, especially for small operating systems. This design was ideal for early computers where system resources were limited. However, as system becomes large and more complex, other kernel architecture was developed. Now, since it has advantages, benefits, it has some drawbacks and limitations too. The drawback includes large kernel size, hard to maintain, small bug can crash entire system. Although monolithic kernels are efficient, they also have several disadvantages. One major problem is large kernel size. Because all services are included in the kernel becomes very large and complex. Another issue is difficult debugging. If any error occurs in the kernel, it can be very difficult to identify the exact cause. Additionally, a small bug in any kernel module can crash the entire operating system. This can make monolithic kernel less reliable as compared to modular architecture. Now moving forward with the traditional Unix operating system, the Unix operating system is one of the most important and influential operating system in computer history. It was developed in 1970s at Bell Laboratories. Unix introduced many concepts that are still used in modern operating systems. Some of these concepts include multi-user system, multitasking, hierarchical file system, portable operating system design. Unix uses a monolithic kernel architecture. That means all operating system services run inside the kernel. Unix became very popular in universities and research institutions because it was very flexible and powerful. Many modern operating systems such as Linux and Mac OS were influenced by Unix. Now, what were the developers of Unix? Unix was developed by Ken Thompson, Dennis Ritchie. They designed Unix for portability and efficiency. Unix was developed by two important computer scientists, Ken Thompson and Dennis Ritchie. Ken Thompson designed the early version of Unix operating system. Dennis Ritchie developed the C programming language, which was used to rewrite Unix. Before this, operating systems were written in assembly language, which made them difficult to move to different hardware systems. Using the C language made Unix portable, meaning it could run on different types of computers. The innovation played a major role in widespreading adoption of Unix. Since earlier the operating system were written in assembly language, so it was very difficult to move it to the different hardware system. Now, using C language, Unix become portable. So it since it becomes portable, so it would be very easy to run it on different platforms. And this innovation played a major role in widespreading of Unix. Now, the features of Unix include multi-user system, multitasking capability, hierarchical file system, security and permissions. Unix introduced several powerful features. One of the most important feature is multi-user capability. This means multiple users can access the same computer system at the same time. Another feature is multitasking. Multitasking allows multiple programs to run simultaneously into the system. Unix also introduced a hierarchical file system where files are organized in directories and subdirectories. Another important feature is security through the file permission. Each file has permission that control who can read, write, or execute the file. These features of Unix made Unix very powerful for both academic and commercial environment. Now moving forward with the components of Unix kernel. The components include process management, memory management, file system and device drives. The Unix kernel consists of several components that manage system operations. The first component, that is process management. Process management allows and handles the creation and execution of the processes. All the creation and execution of processes is done in the first component, that is process management. The second component is memory management. In memory management, the allocation and protection of memory is managed. The third component is file system, which organizes files and directories on storage devices. Moving forward with the fourth component, that is device drive. Device drive allows the operating system to communicate with the hardware devices. All these components work together to ensure that the system runs efficiently. Now, how the processes are managed in Unix, let's see. A process management is one of the most important functions of Unix kernel. A process is a program that is currently executing. Unix can run multiple processes simultaneously. The kernel manages these processes by creating a new process, scheduling processes for CPU execution, terminating processes when they finish. Unix uses time sharing techniques so that multiple users can run programs at the same time. Each process receives a small amount of CPU time, which creates the illusion that many programs are running simultaneously, since it supports multitasking. Now, memory management in Unix include that it controls allocation of the memory, handles virtual memory, ensures efficient memory usage, protects memory between processes. Memory management is responsible for controlling how memory is used by the processes. The Unix kernel allocates memory to the processes when they start executing. It also ensures that processes do not interface with each other's memory space. Unix uses virtual memory, which allows program to use more memory than physically available memory. Virtual memory uses disk storage and as an extension of RAM. This allows the system to run on large programs efficiently. Now, how a file is organized in Unix. The Unix file system organizes file using a hierarchical structure. At the top of hierarchy, it is the root directory represented by the symbol slash. All other directories and files are located within this root directory only. Each file in Unix has attributions such as file name, owner, permission, size. Permissions determine who can read, write, or execute the file. This structure makes file organization efficient and secure. That is why it supports file operation and handles data storage efficiently. Now, let us compare it with the modern operating system. Modern operating systems have evolved significantly from early monolithic design. Many modern systems uses modular or hybrid architectures. These designs allow components to operate independently, which improves system stability. For example, if a driver fails in a modern system, it may not crash the entire operating system. However, some modern systems such as Linux still uses a monolithic kernel with modular features. This provides both high performance and improved flexibility. Now, let us conclude the topic. In this lecture, we have studied monolithic architecture and a Unix kernel. We learned that monolithic architecture integrates all operating system services into a single large system. This design provides high performance and fast communication between the components. That is traditional Unix and a modern system. However, it also has some disadvantages such as large code complexity and risk of system crash. Also, it is harder to maintain and scale. The Unix operating system is one of the most important example of a system that uses monolithic kernel architecture. Understanding these concepts help us to appreciate how modern operating systems have evolved to balance the performance, reliability, and flexibility. Now we reached end of the session. See you soon in the next lecture. Thank you, everyone.